And now we're going to bring on our next guest.
With that,
we've got Dan Romano, who's joining us from the crew over at COSMIIC.
Hello.
Hey, Dan, how's it going?
Good. How are you?
Not too bad.
Good.
All right.
We've been really lucky to work with the COSMIIC crew on quite a few things in the last year on our healthware initiative. So we're pretty jazzed on everything they do. We've, I think y'all have been basically involved from the start of the healthware campaign.
Yeah, no, it's been great. I think my colleague Chris has kind of taken the lead on all of the open source stuff, especially with OSHA. So I'm excited to kind of do my part and share a little bit about what we've been doing recently.
Amazing. Excited to hear.
Okay. All right. You just make sure I get everything set up here. Okay, great. So yeah, we are COSMIIC. This is an open source implantable medical device, which is pretty exciting. It's the world's first. And I am Dan Romano, a biomedical mechanical engineer on the COSMIIC project. Again, my colleague Chris gave this presentation last year, so I'll give an overview of what our project is, the progress we've made, and then where we're headed. So we're looking to solve the common issue that researchers and startups in the neuromodulation space face, which is gaining access to human-grade tech for new studies. For groups looking to develop their own device for their therapy, it can take decades and tens of millions of dollars, which is just unrealistic for many early-stage concepts. Next, researchers look to strategically use existing devices from major manufacturers, but they could experience inflexibility of the device and organization and possible licensing complications. So across all of this, there's a massive suite of documentation and validation testing required for regulatory submissions. These factors combine to stifle the ability of academic researchers and early-stage startups to advance their science towards human use with implants. So we need to instead allow developers access to implantable technology and supply resources for the complex regulatory stage. So what is COSMIIC? COSMIIC is an NIH-funded project through the SPARK program. The Hornet grant allowed our group to take a previously closed source device and make it an open source device. For the past 3 years, not only have we been taking something that was closed and making it open, but we've continued implanting this device through our early feasibility clinical study, as well as adding new features to it. So the COSMIIC system is a fully implantable modular device with stimulation and recording capabilities. It was formerly known as the networked neural prosthesis. And one of the more important features of this device is its acceptance as an investigational device for human use, which has been implanted in 10 people over the last 6 years. So we chose an open source approach because it lowers the barriers to device development and ultimately to clinical adoption. By making the system modular and openly available, researchers and clinicians can customize and adapt components to their specific needs. And then this just accelerates innovation and collaboration. Open source design also promotes equity and transparency in human health, ensuring that knowledge and tools are accessible rather than proprietary. Finally, fostering a community literacy around device design and use helps combat device abandonment by empowering users and institutions to understand, maintain, and improve their technologies over time. So here's our current use for spinal cord. So our current use for the device is for spinal cord injury, specifically for hand function. So our patient population is cervical spinal cord injury. And many able-bodied people are under the assumption that walking would be the most preferred function to regain. However, research shows that people with spinal cord injury place emphasis on finer activities related to hand and also bladder bowel function. So we're really looking to improve activities of daily living, such as eating, holding and drinking a cup, brushing hair, and then also like grasping a tennis racket. And our participants are parents, siblings, employees, pet owners who need these functions to take care of themselves and others. So here's a diagram showing how our device is currently implanted for hand and trunk use. So our modules, or these gray rectangles that you see throughout the body, they are implanted throughout the abdomen, the chest, and the arm. These are all physically connected by a network cable. And then we have electrodes that come out of these modules and get implanted in the belly of a muscle. And then those electrodes are going throughout like the forearm and hand. So in this configuration, we can stimulate 12 different muscles in the arm and hand to generate grasp patterns. So different grasp patterns could be like a key grip, where it's just like flexing the thumb, or it could be like holding a cup, different grasp patterns like that. And we can program that after we've implanted these electrodes. So our base COSMIIC system components are a power module, which controls all of the power communication of the system. It has 3 batteries in it, and it can be wirelessly charged. This is what is implanted in the abdomen and is like the largest module. We have an IPG, or an implantable pulse generator, that delivers the stimulation to the muscles. And then we have a biopotential recording module that can read MES signals or muscle activity to help control the device. So our network cables connect all of the modules physically, and then we have a few different types of electrodes for stimulating or recording. And then we also have a few external components. We give participants a smartphone with an app that allows them to choose like which grasp pattern they want to use. And then we also give them a water-cooled like wireless charger. A great benefit to being open source and having a modular system is our ability to add modules that can have new features. So we're currently developing 3 new modules that can target new areas of the body and return more functionality to daily living. So we can improve mobility or pain management or brain-computer interface, or like BCI. We're also developing adapter cables so we can connect with other implantable devices or implement new types of electrodes into our system. So another benefit of this system is how it's translational from benchtop to animal to human use. We have a software development kit and a MATLAB interface that allows researchers to test and prototype their therapies on the bench. It's a simple introduction into the system, and they can verify the software and firmware can meet their needs. We can then use that same benchtop kit to do percutaneous studies in animal models. But if they want to do an implantable study in animals, we can actually take the rigid flex circuit board off of the SDK. We can roll it up, pot it in epoxy, and implant it. So it's the same circuit board that we use in like our human grade system. The same circuit board is on our benchtop development kit. So we have a few animal study collaborations going on that are using different setups, but we're in the process of creating a standardized animal version to the system. And then the final step is to translate their animal research into the human research. And this process, like I said, uses the same circuitry and software throughout. So our resource ecosystem is built around the base components of the device and its surrounding knowledge base. I'll focus on open source materials first, and then we'll talk about resources near the end. So all of our mechanical design files are on our GitHub. This is an exploded view of our power module. And so you can search through all the different components we have, not only on this screen, but here's one of our remote modules. So in particular, this is the pulse generator that delivers stimulation. And then here's an example of some of our cables that we have. So all of this is on GitHub. I can access it through our website. And yeah, it's been up there for a while, and we're continuing to add to it as well. So our success criteria at COSMIIC is is, well, our success criteria for being an open source medical device is helping a researcher or startup get their regulatory approval for human studies faster, easier, and cheaper. Our documentation enables someone to make the device and figure out how to use it, but to achieve regulatory approval requires a lot of assistance because this is a complicated task to accomplish. The medical device product lifecycle is inherently complex, requiring significant resources to demonstrate design verification and ensure compliance with rigorous regulatory standards. Each device must undergo extensive testing for biocompatibility and sterilization. You need comprehensive risk analysis, and clinical validation provides the evidence needed to support safety and effectiveness. Beyond development and testing, successful adoption also depends on establishing standardized surgical techniques, refining clinical programming, and developing methods for accurately measuring patient outcomes. So how does open source apply to medical devices? So in the medical device development, the valley of death, you see there, refers to a critical gap between early stage research and successful commercialization. It occurs after promising academic or prototype work has been completed, but before sufficient funding, regulatory approval, and clinical validation have been achieved. So bridging the valley of death requires not only technical and regulatory expertise, but also clear evidence of clinical value, market need, and a feasible pathway to manufacturing and reimbursement. So that's where COSMIIC comes in. COSMIIC is built to help bridge the gap over the valley of death by offering an investigational device exemption and biocompatible foundation. The COSMIIC system reduces the time, cost, and expertise needed to develop new neuromodulation therapy. Researchers can rapidly iterate and test new therapeutic ideas using standardized components, which lowers technical and financial barriers that often stall innovation. In doing so, COSMIIC enables academic and startup teams to advance promising concepts past the high-risk development phase and toward clinical and commercial readiness. So we are trying to meet researcher and community needs by sharing. We are sharing our design history and design files, biocompatibility testing, sterilization, validation, and our regulatory approvals and communications. This information is already on our website, and we're continuing to add to it. My colleague, Chris Rexroth, and myself have started Open Neurotech to be the supply chain management of the COSMIIC system and future iterations. So we will work with the nonprofit to be the maintainer of the open source resources, but Open Neurotech will supply the physical hardware for the device, as well as providing consulting services for help with regulatory process and for general use and alterations of the device. We're actively writing letters of support to researchers wanting to use the system, as well as to make quotes for them. This technology is available for purchase, so if you're interested, please check out both the COSMIIC website and Open Neurotech's website, and don't hesitate to reach out. So it might be a little confusing of all these different entities going on, but COSMIIC is just the community, it's the project, it's the device, and Open Neurotech is the entity in which you can actually purchase the device and seek consulting or help for it. So the COSMIIC system is more of a platform technology at this point. We have the SDK available. We have a low-cost animal system in development and the human-grade system that's continuing to be implanted in people today. We're continually adding to and improving our documentation that's online, and we'll be adding our new modules to our GitHub and COSMIIC website soon. So our ideal future for this project is having a collaborative ecosystem. We want researchers and startups not only using our device for their new therapies, but we want them to contribute back to the community too. We want new collaborations to form that develop new modules for the system. We want to highlight the successes of researchers that get awarded regulatory approval. We're slowly building up this community, and it's exciting to see the growth we've already achieved. So this is the end of the presentation, but please go to cosmic.org to learn more about just the device in general and all the different projects that are going on. And then you can check out openneuro.tech also to see how you can buy the device. So thank you very much.
Oh, thank you so much. That was so great to hear you like just really get in depth about the project and explain everything to us. You guys have also been really involved with the healthware project initiative since the beginning. Do you want to talk a little bit about that, about your involvement with the project?
Sure. Chris and I went to a couple of the open healthware like progress meetings this past summer, and so we've been seeing what was required out of like a open healthware certification, or if that was necessary. We talked about again like an open healthware certification, what is open healthware, how it relates, and if something is considered open healthware, like what does that mean? And so we've kind of been just a part of those conversations, and we're excited to see how open healthware and open hardware will go in the future.
Amazing. And then we did also get a question in from the lovely Concrete Dog, and he's wondering, super cool stuff, which we agree. And he's wondering, can it interface with Octave rather than MATLAB to keep the tool chain open?
Yeah, that's a good question. Question probably not for me, but right now it's just we just have a MATLAB interface. But I'm sure I can take this back to one of our software developers and get back to you.
Amazing.
Awesome.
Okay. Thank you so much for coming on and giving us an update on where COSMIIC's at. It's always really great to see how these things are progressing. And I feel like we've been very lucky because of the Healthware Initiative. We've gotten a much closer view than a lot of other folks do get. Yeah. And it's just great to be able to have other people see what y'all are up to.
Yeah, that's awesome. Well, thank you so much.
Thanks.
See you next time.